My name is Anthony Bishopric. I am an engineer at Box, which is an online collaboration and file sharing platform. And so I'm going to give a talk on sort of building a culture of quality, what quality and a culture of quality, what those could even mean, and kind of steps that you can take to get there. Before I start, just a bit of context. Again, this presentation is fundamentally meant for, I envisioned this being primarily for sort of early startups and also larger companies that have a more traditional QA process and sort of ways to get closer to something a little bit more progressive. Okay, so about me, I'm an engineer at Box. This is my fourth startup. I've been the lead developer everywhere except at Box, and that implies that I have had a lot of experience sort of learning the hard way. I've gone through the scaling of a software team and products several times now, encountered many of the same challenges and different ones too. I've sort of refined a little bit of kind of like how I address quality and even just engineering problems in general. About you, I kind of expect, so I think that this is it's a good presentation for a lot of people. I think the CEO of your company could be in this presentation and have it make sense. If you're a manager or an engineer or you're on a QA team, I think all these are applicable too. As far as your sort of perception of the world, you should ideally be living with growing pains. So if you're at a startup and your startup is growing very quickly, you're probably quickly experiencing what it's like to have new developers creating new code and the sort of like learning curves and then sort of getting like bug tracking in place. You should be feeling those pains. That's a good thing to be feeling. You should be excited and also anxious possibly about the reception of your product. Is it going well? Is this a question that you have? You may have questions about how to scale your software engineering team without sort of creating unnecessary bureaucracy, which is a big concern I know for lots of people in the sort of startup world. How do you do that? How do you create like a safe software that can be that can scale, that doesn't require introducing a ton of process and bureaucracy? And finally, how do you plan ahead, sort of like, or how do you actually plan ahead and create sort of like a long-term strategy for yourself without also, overbuilding? Cargo cult programming is this concept that takes place in the pragmatic program. No, sorry, Mythical Man Month, and it's this idea that you can overplan and build systems that don't make sense, even though you think they will in years away. And in general, if the concept of quality sort of seems like cloudy and hand-wavy, good. That's exactly where I was before I sort of worked on my projects, and now I think I've distilled a couple good ways to describe quality. So when I joined Box, there were about 40 engineers, and there's over 120 today. There was lots of pain around technical debt. We had a weekly release process that was functioning pretty well with a sort of centralized QA model. A very low bus factor. If you don't know what bus factor means, it's the number of people that would need to be hit by a bus in order for your company to sink into the ocean. So that meant that we only had a few people who were, sort of knowledge bases for the whole company. And we were hiring like crazy. We were hiring a ton of people. We had a huge sort of scaling plans. We had a big market to tackle, still have a big market to tackle. And just in general, I heard this over and over from many of the people when I joined. It just seems like it was impossible to slow down. Like you were never going to get to a point where we could like stop and think about how to do things better. I don't think that ever crossed people's minds, or it didn't as much as it does today. Again, the gist of this whole presentation is going to be like, what the hell is quality and how do I get it? It's sort of like, it seems so nebulous, and if you're in the weeds, it's kind of even hard to approach this topic with like a rational mindset. So this is about sort of approaching how we can get at these things. So our agenda for the presentation is going to basically be three things. First, we're going to just try and get a good sense of what quality is or what it could be. And then we're going to talk about what a culture of quality is, which is a little different. And then the third point is just how do you actually get there? How do you actually build a culture of quality? So let's start with what quality is. Obviously, this question has a very, very complicated answer. If you've read Zen and the Art of Motorcycle Maintenance, you know that the guy goes totally Looney Tunes trying to decide what quality actually is defined as, and goes through all these things about like, oh, like classical quality versus romanticized quality, and yada yada yada. So we're not going to do that. We're just going to limit our definition of quality to sort of software quality, and we'll get a little bit more narrow from there, just to keep ourselves sane. Lots of people have different opinions on what quality can be defined as. Here's our CEO, sort of giving his 2 cents on what product quality could mean. We're not going to go with this one, but this is an interesting one. It's definitely it's measurable. The Consortium for IT Software Quality defines quality as having all of these attributes. You know, it's reliable and efficient, and it's secure, and you have a maintainable software system, and the size of the software system isn't too large, right? Like the smaller the size of the system, in general, you can claim that you have higher quality. Okay, so these are all very nice, and they seem fairly obvious too, and like you can sort of like say, like if you have these things, that you have high quality software. It's nice. But I don't derive a whole lot of sort of actionable agenda items from this. Like just reading this, I don't immediately know things like, well, which is more important? Can I have all 5? Can I actually build an engineering organization that has all 5? Does it matter? So questions I have about this are that it's maybe just too generalized, and also really not something I can act on as effectively as I'd want. So we'll keep this in mind though, because I think there's some good things in here. Obviously, I mean these are good qualities to have in software. I think most people would intuitively agree. But how do we get to something that's actually a little bit more actionable? So let's get some better questions for ourselves. What does it mean for my software to work well? What does it mean for the product that I'm building to actually achieve its goal, achieve its sort of promise? Like what are we saying it can do, and what is it actually doing, and how is it meeting that requirement? That's a very abstract question, but it's something you can ask given any kind of product. So like, for example, a banking website, I really want it to be secure. I really don't want people to be able to launch transactions that I didn't authorize, and I just want to be able to see my statements. So there's some value in simplicity, there's some value in security, but I mean, maybe those are how you define how that software could work well. Also, related question, highly related question is, how important is it for my software to work well? Well, is it really important to that the bank site work really fast, or that it has high security? I mean, I honestly would prefer the latter. I hope you would too. And a third question, which maybe is a little bit less obvious, but it is if you are in a high-strung world, is, you know, you could be product or you could be an engineer, but maybe you have this perception that engineers at your company are stuck. You know, like you said that you laid out a product specification 3 months ago, and it just seems like nothing's happening. Like you don't see any progress. You hear frustration from engineers. As an engineer yourself, you just feel like nothing is happening. You're not moving. You're in meetings all day. Yada yada. You know, this is maybe a related question too, right? If it's hard to actually do stuff, if you're stuck, does that mean that you have low maintainability? Maybe, actually, yes, maybe, I don't know. It's just a question that you could ask yourself, like, that might relate to software quality. So actually, I'm going to give a very concrete reason why all 3 of these questions are related to each other, and that is because they all have to do with at least achieving how well something can work, or getting engineers less stuck, whatever that means. Those are all questions of time management and speed. I think speed plays into all of these previous questions, and sort of, you know, there are lots of key metrics that you can use against time that show, you know, how well your organization is running, right? Like how much time is spent fixing bugs? Great question, right? I think you could claim that if you spend half the amount of time fixing bugs, you could say that you have higher quality. I think this is a generalization you can make roughly. What is the average time to bug resolution? That's another time-related question that could imply better quality. There's other things you can use too. So time, I think, ends up being at the sort of core of a lot of quality questions, right? How much time does it take to do X? Sort of implies a lot of quality questions, and time questions all share one very important common ancestor, which is that they're also money questions. The developers are expensive, right? And so you can essentially equate time spent by a developer into dollars spent by a developer, right? Like if a developer comes in and it doesn't do anything all day and is in meetings all day, you might as well just like take a like big screen TV and launch it out the window, because it's like not like you've gotten very much done, and you know, that's time spent that could have been spent on other things. Quality, I think, roughly comes into that. So what am I talking about? I mean, I'm sort of just generally saying that time is money and that time is somewhat related to quality. So I'm going to go ahead and give you some sort of formal, actionable property of quality that I will be working on for the rest of the presentation. But before you do that, I'll just give you an assumption, which is that every bug that is in your software system, and I'm going to go ahead and say a bug is sort of like lacking functionality or failure to sort of meet some promise of what the product does. Anything that's worth fixing will get fixed. It's sort of like a guarantee, right? As long as there's problems in the software that you're trying to sell and they're worth fixing, i.e. there's some customer that's angry about it, that's worth it to the business, they will get fixed. So for this reason, you can treat bugs as sunk costs. A bug that appears that has to be fixed will get fixed at some point by some developer, and it will cost some time, S, to actually fix that bug. Guaranteed. It's a sunk cost. As soon as that bug appears, it has that cost. And I mean, this intuitively seems true, right? I think everybody would agree with that. So let's actually say that based on the fact that basically you can equate bugs to a cost, some cost that would actually be probably related to time, then I'm going to go with this actionable property of quality, which is that quality is just inversely related to the total cost of engineering. So Q is related to, not necessarily equal to, this is not the definition of quality, but this is a relationship that as engineering gets more expensive, quality goes down. So doesn't this seem pretty broad? This seems like a pretty broad definition. I'm going to go ahead and make this claim. I think an organization should be able to measure anything the engineering organization creates against the value it generates. And remember that also QA groups aren't like created by the C-level team just to make the number of bugs per release go down, right? They want, I think there's this thinking that, you know, if I introduce a quality assurance organization at my company, my software will trend towards being as high quality as Apple's, right? Like, that's what I want. I want just like amazing quality, right? Like, and that's what I'm doing when I'm paying for QA engineers. But it turns out that what we've done in our industry is we've constricted the definition of what a QA team does to just reducing the number of bugs per release. And so it misses a whole bunch of dimensions as a result. So let's talk about this definition. So when we measure quality as being just inversely related to the cost of engineering, we get to say that all the time spent on establishing security and reliability and performance and everything else that Dr. Bill Curtis said at the Consortium of IT Software Quality is included in this definition. Further, we actually have new extra things we can measure, which I think everybody would also agree are pretty important, like time spent adding new features has some relationship to quality. Training new hires. How long does it take to get a new hire from knowing nothing about your software system to knowing enough to be able to write safe code? How long does that take? That's a good question. How long does it take to do pair programming? If you're an organization that does pair programming, that's some fixed cost. It has some education cost, and you can measure it with time and essentially money. So I'm going to go ahead and make this claim that quality can be just related to how expensive your engineering organization is. So to convince you of this, I'm going to go ahead and give a couple sort of working examples. But I know this is going to be this is a little rough if you're coming from a sort of traditional QA world, so I'm happy to take questions at the end. So here's the example. In a traditional world, let's say we have a product and it introduces 100 bugs every release, right? So we say, okay, our traditional QA process is going to be to introduce a new pre-release testing program, and we're going to aggressively go after every new change that gets introduced into our code base. And let's say the end result of that is that we've eliminated half of those bugs. So now we're releasing 50 live. And so now you could say that, and let's just assume for now, this is not actually true, but that if a bug doesn't go live, it doesn't exist, right? And so therefore its cost is nothing. So let's just say we've halved the cost of bug fixing and that we have higher quality, okay? I'm going to go ahead and make the argument that this is equivalent. The time to diagnose and fix a bug is 8 hours. So now let's say as a QA organization, we're going to go ahead and introduce a new debugging tool that cuts the time to diagnose and fix bugs down to 4 hours. And now what we've done is we've also halved the total amount of time or cost to fix bugs, and therefore we have doubled the quality. I make the claim that these two things are equivalent, and that it's not fair to actually just restrict yourself to this left definition when both have an equal engineering cost. I'm not going to include like customer cost of bugs, of like going live, like whether or not things are going live. I think there's totally a real cost there, but from an engineering organization, this is measurable right now, and that other thing is not easily measurable. So here's another thing. Let's take this graph. I have this is something I pulled out of our bug tracker, right? And by all accounts, it's terrifying, right? You look at this and you're like, oh my God, we have so many bugs. These are number of open bugs on the site, right? And that's the number that we're resolving. And this is a divergent graph. And we're terrified that that our quality is sort of falling as an organization. Okay, scary enough. But let's establish, is this actually a measure of falling quality? So back on our assumption, any bug worth fixing will get fixed. So if we can treat bugs that have to be fixed as sunk costs, and let's just say that that orange bar are bugs that have to be fixed, then yeah, that is actual cost of the organization, and we're not resolving them fast enough. This is a sign of sort of like of quality getting worse. There are a higher number of bugs on the site today than there were before, and that's just a higher cost over time. So yes, that would be a higher thing. But there are good reasons why this actually isn't a good metric of falling quality. There's no guarantee that these things, if you're familiar with Jira or bug tracking systems of any kind, you're probably aware of the fact that lots of times you end up with lots of open bugs that just might be duplicates or invalid because they're not actually a bug, or maybe they're just like filed incorrectly. You know, if you have a like public-facing bug tracker for your customers, then they'll file anything about anything. Maybe it's not worth fixing. So it's worth establishing that this might be a definition of a sign of falling quality, but it's not definitely a sign of falling quality, because this doesn't actually tell you whether or not the cost of engineering for bugs that have to be fixed is rising. But let's look at this graph. So this is a dual axis graph. So the orange bar is actually being measured by this vertical axis. And what this is saying is that, the orange bar is actually the average time to resolution. So we actually go from Q1 to Q4, we actually raise the total average time to resolution from approximately 4 hours up to 8 hours. And so this red bar is just like on the previous graph, this is the number of bugs that got resolved over the year. So now we're saying that the number of bugs that we're resolving is rising, and that the average time to resolution is rising. Is this a sign of falling quality? Absolutely. The cost of engineering has like quadrupled or something, right? Like we now have to spend that much more time fixing bugs, and you didn't have to use any open bug tracking at all. You were able to just take concrete, actual things that did get fixed. I mean, these are bugs that we know had to be fixed, right? Because they got fixed just by virtue of having been fixed. They are sunk cost. So I'm going to go ahead and call this yes. These are definitely a sign of falling quality. We are taking longer to fix bugs, and there are more of them.
Why do you trust the average time to fix measurement? Why do you trust that measurement? Maybe 4 quarters ago in the beginning, people didn't do a good job.
Yeah, I'll get to that actually. That's a really good point.
The other thing is, you can't just look at number of bugs. You have to look at the rate. So bugs per lines of code, something like that. You can have a lot of bugs, but if it's spread over 1 million lines.
Could you argue that I would argue that your quality drops if you have more bugs? I mean, so there's this other component of this that can come across with just like feature value, right? And that's not captured in this. Yeah. But yeah, let's actually talk about that afterwards. It's really interesting. So here's sort of the next step, right? Like based on the previous graph where we actually say that is definitely a sign of falling quality. How can we now act against it, right? How can we establish that we need to be able to build something that actually reduces the time spent on bugs, because effectively that concretely will improve quality by reducing the cost to fix them. So here's a graph that you could theoretically produce for anybody really. If you have some way to measure the average time spent on bugs, which we do apparently, because we had it in the previous chart, then we introduced this new debugging tool in week 4. We now end up with a consistently lower average time to spend bugs on a week-by-week basis. And so you can make this claim that you've actually improved quality by reducing the amount of time you spent on fixing issues. So I really want to stress it's really important to be able to sell yourself on this notion of quality. I think that in general, it's important to find a big win. So like this could be something really simple, right? This new debugging tool could just be something like just running xdebug if you have a LAMP stack. Something that lets you quickly identify the source of issues could save you lots of money over time. And I think this is the responsibility of the quality assurance organization to do, not just to eliminate the number of bugs per release. So yeah, I know there's probably a lot of questions about this concept of quality at the end, and so yeah, again, I'm happy to sort of talk about this at the end. One caveat about metrics, and so this is related to what you were talking about. So they should be relatively easy to measure. You should be able to measure them 6 months down the road, and they should not vary in what they mean, right? So if you need to come up with a crazy database of like convoluted measurements over like time and other crazy things, like if you spend a lot of time on metrics, then you'll defeat the value of them, because the easiest and most obvious ones to measure are probably going to get you the most important information. In a very related way, accuracy is less important than precision. And what I mean by that is here in this previous graph, you can see there's some fluctuation week over week, but actually the trend is what I'm really trying to identify, not the actual value. Like really, I want to be able to show that by introducing this dropped. I don't really care if it's exactly right. I care that it actually shows a trend with changes that I've made. That way I can say that I'm improving quality. And third, just the other caveat is that data can be used to do anything and point to anything, so use it wisely. I've seen it done, so yeah. The last thing actually, and just to address your point, you can have rising engineering cost, which could be matched against feature value, right, at a one-to-one basis. So let's say you have like millions and millions of lines of code, right? You may be generating way more value than the quality cost of it, but it's important to understand that often, like as a first step, most organizations do not have even this or the feature value aspect of it. So to start, it's worth at least acknowledging that quality is expensive and trying to reduce that. And maybe you end up in a world where now you're sort of unfairly weighting against quality when really it's sort of a feature value problem. But it's worth at least starting with this and then moving forward. Like when you're engaging your product organization to actually establish what feature value is. So yeah. But before we get there, let's just focus on quality and get some ideas of how to measure it. So lastly, I'm not going to read through all these obviously, but this is just there's a bunch of ways you can measure quality this way, and all of them are valid. And my main point is to not get caught on this one. It is a very small aspect of the bigger problem, which is just total cost against engineering. So yeah. So yeah, that's enough on sort of giving like a actionable property of quality. And so now we'll talk about sort of what is a culture of quality. So this is a very different question, right? We're sort of done talking about like how do we get a numeric way to describe quality, which may not be like accurate or complete, but let's move away from that and go towards something where we just try and talk about what does a culture of quality look like. And it's the sort of thing where it's kind of like I know it when I see it, right? Except it's not pornography in movies, it's actually sort of quality. And it's hard to describe. I had a really hard time coming up with like one specific way to describe it. It's not like something I can put into a sentence. Yeah, I can tell you that there are certain things I can see at an organization that has a culture of quality that are very important, that promote the kinds of things that we're talking about in this presentation. So number one, most important thing, no question, is having lots of trust and open communication. If you do not have this, if you cannot go up to people and tell them like what's wrong with the system or suggest something to make the system better, or have a frank conversation about how things are working, then it's already over. You cannot create a logical, rational workflow that makes changes for the better if people have too much emotional tie-in. I mean, this is a really common problem. If you're engineer number 5 and you join the organization and engineer number 1 has created a whole system that he's very proud of, and you realize it's just not going to work, like you have to have a conversation about it. And if you don't, then you're never going to be able to like get any of these incremental steps to improving the quality of the software. So yeah, having really good communication is definitely a sign of good things. This is a little bit more technical, but in the vast majority of the time, I've noticed that engineers tend to be vertically sliced in a culture of quality. And what does that mean? Well, this concept comes from Agile, and its original intention is actually to essentially let each engineer complete one sort of functional unit of work, right? Like you give them as much access to the full stack as possible so that they can complete a whole unit of work. And it's very clean from an agile perspective because then you have something demoable at the end of the week or 2 weeks or whatever. And I think that helps with planning. But actually the reason why I like engineers being vertically sliced is not so much that, but because of what it does to empathy. It actually, when I've noticed that in organizations where there are more horizontal splits, more component splits, you end up with people that don't totally understand the scope of problems that other people are dealing with. So for example, we have a front-end engineer and a back-end engineer and a tech ops engineer and a quality assurance engineer and a performance engineer and a security engineer. They all operate in their own worlds. And so as soon as you bring up something like, well, this one feature is not performing very well, so somebody on the performance team, and then somebody on the front-end engineering team is like, it's not my problem, I'm not a performance engineer. Or like the same problem, this is the same classic like conflict and tension between operations and engineering always, is that there's people that have a focus on stability and then you have a focus on people that are just trying to build new products, and they both have valid perspectives, but neither of them can get together unless you have a little bit more empathy. So this actually really helps build, I think it actually really helps improve sort of the open communication flow of things. Yeah, I think it's a very subtle difference, but it really does help. Okay, yeah, this one's really true. Google is based entirely on having a giant organization filled with nerdy people. I mean, I love nerds. I think nerds are the ones who are going to challenge the status quo the most. They think things about more. They generally care more about how things are structured, and most of the time they express their thoughts particularly well. I think nerds can be compelled as much with logic, probably more so with logic than with emotion. Very important, subtle, and generally underappreciated quality about people that are very logical and rational. Yeah, I like nerds because they also they generally aren't the kind that come in, do their work and clock out at 5 and they're done for the day. That doesn't tend towards a organization where everybody cares about the quality of what's happening. So yeah, to the extent possible, hire as many nerds as you possibly can. Experimentation is encouraged. So you should have, there should be some aspects of the organization which let you experiment, right? And there should never be like no, this is absolutely wrong. Maybe unless there's concrete evidence to show that, there should always be some mechanism by which you can try new things. Even if they're silly ideas, even if you just get them out of the way, or you can point somebody to like some set of experiments that showed that it didn't help, that's good. It means there's no like emotional way that you can like reject somebody's idea, because I think this is a general problem that goes back to open communication. But as long as you reject somebody's like conceptual experiment before it's even been tried, I think you end up not having concrete evidence, and that's really bad. Great cultures also, allow failing fast, and experiments really allow this. They really facilitate it, actually. It's easy to take care of an experiment before it becomes a serious problem versus just trying a whole thing, like a giant overhaul, and then letting that become a serious problem. So I think this also helps alleviate sort of just like fear of change, which can also happen. And so here's a sort of like higher level one, self-actualization. Happy people aren't freaking out about where they'll work next. You know what I mean? Like, this actually ties back to something called Maslow's hierarchy of needs, I think. And the idea here being that self-actualization is sort of like the highest place you can get in terms of your comfort level as a human being. And so here's generally, if you can see this, generally the idea of Maslow's hierarchy is that you have these base needs that you need to have met before you can go to the next level. And if you're missing anything on the lower level, it's pretty much impossible to get to anything at the top. So in a culture of quality, I've noticed that the company is really capable of providing all these things, self-esteem, confidence, achievement, respect, and in exchange, they get all of these. Creativity and great problem-solving skills, and lack of prejudice, and surprisingly important acceptance of facts. It's funny how that's not a thing all the time, but you have to have a culture where you respect each other. So I mean, what we do at Box is we actually have demo days, and we have a number of different things that we do to essentially like promote when somebody's done a good job, and I think that helps build a culture of quality a lot more than you might think. So this is actually very important. And also point out that if your startup has some of these going on, you're not in a good place. You can't possibly expect people to be creative and have a lack of prejudice if they are dealing with a situation which is not particularly good on the morality side, or it lacks safety, or you're not getting sleep, or you're having to move every couple hours to a new cafe. There's a number of things that homeostasis is actually subtly important too. Yeah, so I think this is a good analogy. So the last two things are related to each other. In a culture of quality, developers are asking themselves, what does it mean to test this? What does it mean for my thing to essentially work, right? And how do I show that it will work on an ongoing basis? And this is the developer, not the QA person. But the QA person asks, how can I make developers more effective? How can I make it easier for developers to get what they need done? And I think this is pretty intuitively obvious. So I'm going to talk quickly about some of the effects at Box. Yeah, I mean, you guys, like, I don't know, if you have specific thoughts on things that we can talk about in this section, please let me know. I just sort of pulled a bunch of things at random. So the very first thing that happened was we realized that there are we have these three groups at Box, QA, release, and tools and frameworks. And then we realized that they all have similar goals. They all essentially want to improve the quality of the software in one way or another. And so we just formed them into one group called engineering services. This is more of a process thing than anything, but what it's allowed us to do is basically have sort of mandates from our sort of like core of just like engineering understanding that we can then leverage across these different groups. It just is a little bit of a streamlining process, but it's actually been very effective for us. Yeah, I mean, somebody in QA can report back something bad about the quality of the software, then somebody in TNF can actually build something to fix it, or we can have somebody in release build a resiliency tool that shows that it's happening before it gets too bad. So this is very effective. We strongly believe in automated testing over manual testing. So here's some made up numbers, but just these roughly parallel kind of like what we went through, but we had a world where we were doing all manual test cases up here, and so total execution time is the triangle measured over on the side, so it took 35-ish hours to execute about 450 tests. And then we sort of introduced new testing frameworks that developers were able to build automated tests with. And so here's the gray in this area graph is the automated tests. You can see that those are rising very rapidly. Around April here, we started replacing our manual tests with automated test cases, and the total time to execute dropped. So not only did we increase the number of things that were being checked for correctness, but we also decreased the total amount of time it takes to get execution. So, I mean, not only do we emphasize automated testing, we emphasize fast automated testing too. We have very few Selenium tests. And the ratio of Selenium test to unit test is roughly around 1 to like 200 or 300, I think. So very, very high ratio. And I think that, yeah, we get a lot of confidence out of these. Developers often feel like that they are more comfortable with the quality of the software that they've built once they have a strong regression suite. And I completely agree with that. So we have this concept of code ownership too. Developers own specific files, and responsibility for ensuring its maintainability and quality sort of falls on the person that owns the files. We report errors from production directly to the code owners. So this sort of like distributes the load in terms of just like debugging. And if you own too much, we encourage you to split it up with somebody. And so what we've done here is this really not only improves our bus factor, right? Again, the bus factor, like we actually semi-automate the process of like distributing load of work to people and owning stuff. But it also makes people sort of ask that question, what does it mean to test my software even more, right? You want to reduce the amount of bugs that happen in the software that you own as much as possible. So just as a code sample, I can skip over this, guys, but I mean, this is actually I'll sidebar for Box very well. Yeah, what we want to do is eventually have the groups be in the file as opposed to being in DevTools, because that's stupid. Yeah, okay. Yeah, but the idea here being that the first developers sort of own everything and then they distribute down. Okay, this is cool. Okay, so next thing is stop the line. Stop the line is an extension of just continuous integration. And if you're familiar with continuous integration, we run automated tests on every single commit that enters into our trunk. If any test fails, and this is a stop the line aspect, we do not let anybody push commits if the build is unhealthy. The only thing that can go into the build, into the trunk now, is a commit that actually fixes it, and we have a tag for that. And this is enforced with Git hooks. Git hooks are sort of our main guy for enforcing quality at the trunk level. Just as part of the experience, if you try and push during stop the line, you get a spaghetti monster type piece of artwork, and that's really lovely. And yeah, people know it. And they also, there is a way that people can find who's responsible for the problem, so they can go pester that person about fixing it. We have a try service called Soul Crusher, and the way this works is when people submit a code review, our try service automatically runs continuous integration. If you fail tests, your code review is downvoted and you can't push your code to trunk yet. Actually, it won't let you push unless Soul Crusher has said that you are safe to go. So Soul Crusher is kind of like acting as a person in our code review tool. And so what this ended up doing is, like, from a time perspective, in terms of reducing time to finding out whether or not there's a problem in your software, what we've done is, by introducing Soul Crusher, you get feedback faster. You get feedback faster than even when you push to the trunk. And so yeah, again, this is all about just reducing the amount of time it takes to get fast feedback. And we do a lot of work to make sure that this runs particularly quickly too. Along the lines of taking advantage of people's spare time, we have something called Performance on the Pot, which is our clone of testing on the toilet from Google. It's really effective. We get all kinds of topics like, how do I here's this cool tool I built to automate Git bisect, to how do I get help on the feature I'm working on, how can I test the performance of what I'm working on, just little like pearls of wisdom to help to think about while you're sort of on the porcelain god. So yeah, that is valuable and sort of silly, you'd think, but we're taking advantage of spare cycles, and this actually is really effective. People like it. Another thing, the last sort of thing I'll talk about with Effect at Box is that we have a quality education group now. And so what we intend for this is to sort of be a think tank that meets weekly of the testers, the SDETs, and regular engineers. I shouldn't say testers, test engineers, and regular engineers. And the questions that come up are like, why is this thing that engineering services provide slow? Or what can we do to improve the quality of this aspect of our software? We generate the agenda on the same day. Discussions are fast and they're very action-oriented, and we have an informal backlog to sort of track what was said last time and what we should do the next time. And we also get a lot of, as a result of this, we get a lot of cross-measure over what people need across the organization. And this yields great ideas like Performance on the Pot. This is where it came from. And the last thing is that this group is collectively owned. This is not just engineering services, but this is everybody at the company. Everybody has a stake in improving the quality of software, and that is important to understand. Okay. So last is how to build a culture of quality, and this is going to be a pretty short thing because I actually expect this to be very specific on a case-to-case basis, but. I'm going to go through the process of the initial step to getting away from a traditional quality assurance organization. So ordinarily, the traditional QA organization does something like this. Developers are writing code, and then they send over the code to quality assurance, and they sort of validate that it works, right? They run a battery of manual tests, possibly some black box test cases. Very rarely do QA groups in this model actually write white box unit tests, so it's like all functional. And then once they're done, they say, okay, here you go, release to customers, and bam, does not work. And all it took was a 5-day QA cycle. Awesome. When we tie quality to time, this is sort of the first thing you can point at as being very, very inefficient in an organization. So the biggest problems with traditional QA, again, manual and black box testing only, so you don't get any insights into the lower level workings of the code, meaning that you're not getting, this is very subtle, but you're not getting important insight into the actual quality of the software itself. With black box testing, you get no sense of whether or not it's hard to make changes. It takes orders of magnitude longer than a good alternative, like an automated test suite. And again, this model limits the definition of quality to just the reducing number of bugs per release. So it doesn't help you with trends over time. It doesn't help you with improving productivity at all. So just as the first steps to getting away from traditional QA, you have to make this subtle change, which is developers will submit code, but instead of testing it for them, you basically say, no, we don't test specific things for you. We'll provide you with all the tools necessary to ensure that you are getting high quality code. And we may provide some form of exploratory testing. The kinds of things that at Box we sort of call are sort of like sanity tests. The things that if it didn't work, the whole system would sort of fall apart. The product would fall apart. So yeah, maybe that's what we're exploratory testing. But we're not going to like run through a list of test cases for you. That's not how we operate. And so what this implicitly does is if you have a sort of only developer-centric automated test suite, what it means is you're basically opening up the door for developers to release their code on their own. This may seem terrifying, and this is where the trust and experimentation and all the things that we talked about in the culture of quality section are become so important, because you need to be able to ride with metrics at this point. You need to be able to show that as you make these incremental changes to your quality assurance organization, you can improve all these metrics. Because you will still end up with this problem where things still don't work, because that's just how software is. It's not like software immediately magically gets better as you make this change. But more importantly, what you've done is you've freed up QA to actually start measuring things that could be higher impact, or things that they just weren't measuring at all before. QA, again, should really be more like engineering services. It should be a holistic thing about making developers more effective, rather than just being an organization dedicated to just testing bugs before they go live. So yeah, why is this good? So frees up QA to group to do higher leverage things. And yeah, it puts quality into the developer's head, right? If you're required to do testing, and your own testing, you're forced to think about how your code will be tested and how will it work even. And this just ends up resulting in longer term, it can result in higher quality things, right? So yes, I think this is a very important first step. Now, obviously, at this point, it's up to you as an organization to decide what the metrics need to be to actually show sort of progress towards higher quality. But this is the first step. So just some general recommendations. Find like a big win metric and action that you can take to reduce time costs. That's sort of the first big thing. You need to promote a culture of experimentation and openness and nerdiness. And you need to be constantly challenging the status quo to do things in a better way all the time. Every organization is different, but the same general principles apply everywhere. So yeah, that's it for this. I'm happy to take questions now.